Hey hackers, Blue Cosmo from CCS here, and welcome to Module 9 of the Introduction to Python 3 course. Today we're going to be talking about exception handling, which is basically working with errors, right? You're handling errors, you're dealing with errors, making sure errors aren't ruining your code and anything. So let's go ahead and go to my screen, and we can go ahead and see that we got nothing here actually. So let's go ahead and open a Python text editor. We're going to be using Python idle as usual. And you can go ahead and save this blank document to your course folder where you're holding all your course folders. And we're going to make a new folder. And this folder is going to be called Module 9. It hasn't really changed this whole course, right? So we're going to open Module 9. And we're going to save a file called errors.py. So now that we have this errors.py file, we can actually get into the world of errors and stuff. So when we're handling errors, handling errors is called like exception. An exception is basically a statement that can handle errors for us, right? We're going to get into this in a little bit, but it basically allows us, so handling our errors allows us to make scripts that won't break, right? Like when you have an error in your program, it will, if there's an error in the program will just terminate and just show an error rather than handling it and not being able to terminate, because there's going to be programs that you make that are going to contain things that could cause possible errors. Things like a calculator, right? And if a user divides by 0 in Python, that's an error. Actually, let me show you. So if we try to divide by 0, let's do like 10 divided by 0, it's going to give us an error. Now, if you have a program that's going to do this, then your program is going to terminate because it doesn't know what you're talking about. You can't divide by 0. That's an error. You can't calculate that. So if you're making a calculator and someone divides by 0, the whole program is just going to stop working, and it's just going to terminate. So you need to be able to try to be able to handle this error, so that way your program will still work and say, well, you can't do this, right? You can't divide by 0. So the first thing we're going to talk about are the different error types, right? So error types. Now, in programming languages, there are 3 main types of errors, all right? The first error is a syntax error. And a syntax error, this occurs when the syntax of a program is incorrect. Let's make a docstring. So if you try to do something like hint hello world, this would cause an error. There you go. So that's a syntax error. It's a double quote missing, right? You try to print hello world and you forget the double quote. So the second type of error we have is a runtime error. So a runtime error, this occurs when invalid data is inputted during runtime. Runtime is basically any time after a program starts running. All right. Now, we can do something like this. All right. So this program asks for integer input, and the user inputs a string. So it'll be like int input what is your favorite number. And then in here we can do that. And then I'm gonna just use this to represent output. So what is your favorite number? And the user will prompt tree. And this will, cause an error, right? I'm gonna do the same thing up here. And the third type of error is a logical error. So this type of error is when a program runs as normal, but not as intended. And this is kind of like the hardest error to find typically, because there's nothing necessarily wrong with the program. It just doesn't do what you were intending it to do. So the program is intended to print their name before their age. So we get their name equals to Bob. Let's say Bob's age is, 25. And we can print an F string. And in this F string, we will put hello, my name is, and then their age, and I am name, years old. So this program will still run. It's going to print hello, if we try to run it, it will print this out. And for their age, it will print 25. And then here, it will print Bob. So it'll say, hello, my name is 25 and I'm Bob years old. So the program will still run. There won't be any errors. It's just not doing what you wanted it to do. It's not doing what you intended it to do. And down the line, that can make your code very complicated very quickly. Save this and we'll make a new file. And we'll call this file tryexcept.py. And we'll clear this whole thing. And so let's talk about try and accept statements. So try and accept statements. Excuse me. So the try statement it permits the developer, which is us, to try a code segment. All right, so actually, hold on. This isn't specific to the try statement. So it try and accept statements permits the developer to try a code segment. I'll put this in all caps just to emphasize. So to try a code segment, except if it doesn't work, it will run a different code segment. Cool. So the try segment So the try statement, we can try code that may cause an error. All right. And the except statement, if an error occurs, it will stop the try statement and run its attached code. All right. So let's try, and we'll just print 10 divided by 0, and then it will print. So anything after this will not run because an error occurred. So this will not print. And then we have our except statement, and this will print you can't divide by 0. So you remember what happened when we tried to divide by 0 before. So now if we try to divide by 0 and an error occurs, except it will see that an error occurred and let us know that we can't divide by 0. So now it's good practice in programming to label or to specify the exception. Specifying the exception is good. It's a good. Oh my gosh! Is a good programming practice. So we can do except 0 division error. So you're like, okay, how do you know what type of error it is? So if you do the code, or if you try to run the 10 divided by 0, it will give us the name of the error, the 0 division error. This gives us the name syntax error. This gives us the name error. So we can specify the type of error by just putting this name right here. So except the 0 division error right here, and then we can say you can't divide by 0. And this will do the same thing as above. And we can specify multiple exceptions. So we can specify multiple exceptions. So we can do like the except, the except 0 division error, and you can also do the name error, and whatever other errors you can think of, I guess. You can also chain except statements. So we can chain except statements, and we can do something like this. And for the first error, we can have it do something if it is a divide by 0 error. So 0 division error. Remember, Python is case sensitive, so when the capital letters in there are important. And we can also do another one. So we can do except. We can do type error. And then we can do print. You can't subtract an integer from a string. That would give us a type error. In fact, we can actually we can just do print 3 minus 2 in that bottom part right here. So if we run this, oh yeah, I'm sorry, we need parentheses here, and we can throw that in here, and we can, so if we run this, you can't divide by 0, you can't divide by 0, yada yada yada, you can't subtract whatever by whatever. So you can see how we can kind of do these error detections to ensure that our code just doesn't stop running when we're trying to make a program, right? So now we can talk about the raise statement. And the raise statement is basically a statement that will display the error that's being it displays the error that occurs. So it displays the error that occurs in the try statement. So we can do and try 10 divided by 0. This will not print. And then we can print, we can just do print like error, and then we can print, we can just raise. And this will raise the error of whatever error occurred. Let's say we don't know what the error is, we can have it be raised so that way we can see what error occurs. So it's, oh, okay, it's the exact division error. So it can kind of allow you to easily detect what error is going on in your code. And you can also add a description to your errors that are being raised. So you can say, I'll do can add description to errors being raised. And to do this, it's pretty much the same. We do print, I don't know, hello world. And then you can raise a 0 division error. And we can input this message incorrect value. And print this will not run, because the raise raises an error. So once the error runs, or once an error occurs, you can't actually run anything after that, because the code will be terminated, right? I'm going to put this in a doc string because it won't run this bottom section with the raise statement being there. Oh, I forgot to. Okay. We can hit this and we can run this. And it would say division error incorrect value, rather than saying division by 0. So I'm gonna put this in a doc string so that way we can still run the script without worrying whether or not, without having to worry about these raise statements. So now this brings us into the world of finally, right? So there's a finally statement. So the finally statement basically runs code no matter what, all right? So, and it comes last in try except statements. Okay, so we can do our, try divide 10 by 0 and accept 0 division error. it will say you can't divide by 0, and then we can have our finally statement, and this finally statement will print, this will run no matter what. So this can be like the rest of your code or something. You can put in your finally statement. So let's run this, and it will say you can't divide by 0. This will run no matter what. So now you can have this section. So this will try to run, right? This may not be printed. This may be printed depending on this error right here. If the 0 division error occurs, then this will run. If an error doesn't occur, then this won't run. This finally statement will run no matter what, right? So now we can kind of talk about assertions. So the assert statement, this assert statement basically uses Boolean operators to test an expression. All right, so I'm gonna do a quick little doc string right here. So if it's true, the code will run. If it's false, the code will raise an assertion error, okay? And this assertion error will basically it will raise this error. It's kind of like where it says like some sort of sanity check or testing your code. So good for testing. So we can kind of do like a account is equal to 100, and we can check. So then we can assert, let's say account is equal to 50, then it will raise an assertion error. Well, I'm not gonna actually do that, we'll do 50. So if we run this, we get the assertion error, account is equal to 50. Because the account is supposed to be equal to 100. So we can have this kind of be used as a way to kind of test it. And we can also add an argument to the assert statement if we want to. And this would be, let me add this down here. So we can add an argument to the assert statement, and basically what this argument will allow us to do is basically return, or allow us to raise the error with a message. All right, and so we can do our account equals 100, and this time we can assert account equal to 50 to make sure if the account is equal to 50, and we can basically do account should equal 100. So if we move this doc string down here and run it, it's going to say assert account equals 50, the account should be equal to 100. So now we know that there is an error in our code and we can actually test it. Now I'm going to remove this doc string right here, just so that way you can run the file without having to worry about some error being raised. So we can also handle exceptions with conditionals, and I'm going to do that in a new file. So save this file, then save as a new file. So we can open up error conditionals.py, and in here we're going to make a try and accept statement, right? So we can use the else statement, and the else statement will run if no errors occur in the try statement. So we can try our so we can try to print our 10 divided by 0. This won't print. This accept statement will run if an error occurs. This else statement will print. This will print if there are no errors. And then our finally will print, we'll just do prints no matter what. So that way we can run this and we can see you can't divide by 0 and prints no matter what. So because that error occurred, the else statement didn't need to run because it will only run if no errors occur. If we comment out this print statement right here and run it, then it will print. This will not print. Well, now it did print. This will try to print, right? So this will try to print, and it did try to print, and it did print successfully because there were no errors. Then we'll have this will print if there are no errors, and we will have this print no matter what. This will print if there are no errors because there weren't any errors, so the else statement print would run the print statement, and the finally printed no matter what. So it's pretty useful when you're making large-scale projects. For the module 9 practice, we will be making rock, paper, scissors, the classic game of rock, paper, scissors, where rock beats scissors, scissors beats paper, and paper beats rock, right? It's a very, very popular game. If you don't know what it is for whatever reason, you can simply research it. So let's make a new file, and we'll call this file rock tech paper tech scissors .py, and we'll save it and we can rerun it. So if you want to do this practice by yourself, go ahead and try to see if you can make rock, paper, scissors by yourself. If you want to follow along with me, then guys can stay along for the ride. You can also try to make some sort of coin counter or money counter, or even like a minimal calculator after using like the 0 divided by 0 exception error thing that we learned. So let's actually get started on the project or on the practice, right? So this will be rock, paper, scissors game, and this was created by Cosmo. You can put your name here, of course, and we're going to use the random module that we learned a couple modules back, and so we can do import the random module, and this is going to be labeled R. So we can do import random as R, and we can loop code and avoid exceptions this way. So we're going to loop our code. So while true, we can print the banner, and we'll print rock, paper, scissors, and then we can do our available options, and then our options are going to be a tuple. And this tuple is going to contain the values rock, paper, and scissors. All right, there you go. So now we can make our option menu. And here we can print, choose your move. All right. And it'll be \n. And I want the banner to print a new line. So let's say choose your move, and then option 1 will be rock. We'll do a new line and then a tab, new line and then a tab, and then we'll ask for option 2, which is paper, and then new line and a tab, and we'll do option 3, which is scissors. And then we'll make a new line and the print statement, and then we will try to get user input. So try to get user input. So we will try, and basically our try statement is going to run the rest of our code, right? So we're going to do user input option, and so the user option is equal to int and then their input, and then option colon space, space colon space, close the parentheses. So the user option is just going to ask the user to input their whatever option they chose, and the computer option we use comp option, so computer option, and this computer option will be r.choice from the options tuple that we made. Cool. So it gets a random option. So if it's rock, we'll say if user is equal to 1, then user underscore move will equal options, and then at the index of 0. Paper, we can do elif user, I just put user, I'm sorry, that's not a variable, user underscore option. So if we do user underscore option equal to 2, we can do user move equals options, and then at the index of 1, and this will be scissors. So we can say elif option equal to option 3. We can say user, I'm sorry, I just put option. If user option, so we'll say user move is equal to options, and then at the index of 2. And we can do the exception, and then this would be our else statement, and this will print invalid option, try again, and it will continue. So now we can shoot, which is basically, play the game, I guess. We can do a new line, and we're going to say rock, ... paper, ... rock, paper, ... new line, scissors, ... new line, and then shoot in all caps, and then new line. And then we can end the print statement. So now we can print your move, and then the user move. All right, and we can close this. Oh, this needs to be an F string. So it will say your move, whatever move you did, and then we can print the F string and say the computer move is going to be an F string for the computer option. Cool. Oh, whoops, I need to add a double quote here. So now, last thing we need to do is, I guess we need to calculate all the losses and draws. So calculate draw would be if the user underscore move is equal to the computer option. We can do print draw, and we can do that like in medium face, and then two new lines, and then we can break, and then we can do we can calculate the loss. So we can do calculate loss and elif the user move. All right, so this is going to be a lot because we're calculating whether or not they lost or not. So try to keep up. So if user move is equal to the options at the index of 0, and the computer option is equal to options at the index of 1, or if the user move is equal to options at the index of 1, and the computer option is equal to options at the index of 2, and then or if the user move is equal to options at the index of 2, and the computer option is equal to options at the index of 0, then we can print you lose, and then we can do a little sad face, and then a \n, \n, and then end the print statement, and then we can break the loop, and then calculate win, and we can just say else print you win, and we can do a little happy face, and then we'll do new line here as well, and then we can break that loop. So the last thing we need to do is make the actual exception. And this exception will basically accept value error. So this value error will be raised if the user inputs something that's not an integer. So we can just do print and then enter a whole number option, and then in some square brackets we can just tell them, make some examples like 1, 2, or 3, and then a new line, and that's it. So if we run this and there are somehow no errors, we can do rock, paper, scissors, so enter your move. So if we enter sandwich, oh, I know, okay. We do sandwich. It will say enter a whole number, right? And if we enter the number 5, invalid option, try again. So during the invalid option, try again, we'll just make a new line. So now if we say, let's choose rock and then computer opt-in. Okay, so computer option. So let's choose 2 this time. And then it says draw. Our move was paper and the computer's move was paper. So I'm gonna make a new line right here, just so that way it just looks a little cleaner. So let's choose scissors, and we win because our move was scissors, their move was paper. And we can rerun the program. So let's choose paper this time, and we won. Our move was paper, their move was rock. Let's go ahead and choose rock, and we lost. Your move was rock, their move was paper, and there you go. So that's it. We made a full functioning rock, paper, scissors game that you can win or lose or draw in. And there's error detection, so it makes sure that the game won't crash if you type in something that you're not supposed to. And that's it. So it works. Again, all these practices are on the GitHub if you weren't able to keep along or anything like that. And in the next module, we're going to be covering functional programming. So this is going to be a little bit cooler. This is kind of a topic that you kind of need to know if you're entering the programming world. So I guess I will see you guys in the next module. So if you guys are taking this on the YouTube version of this course, then feel free to leave a like, subscribe, and check out my content and all that other stuff. If you guys want to, you guys can head over to my website where you guys can take this same course, but it's organized a little bit better. You guys can take your quiz. You can quiz yourself by taking quizzes. You have easy access to the course overview, and once you finish, you can get a certificate for about $15. But the course is still free. The only thing that you are paying for is the certificate if you want it. Yeah, just to show that your friends and your family that you're able to finish the Python 3 courses successfully. But if you are doing that, that's up to you. Do whatever you want. But I will see you in the next course or the next module regardless. So that's going to be it. Stay happy, stay positive, and as always, happy hacking.